We are considering the topic solution and solubility. Solution is a uniform or homogeneous mixture of a solid in a solvent. There are many types of solution. You have a saturated solution, you also have a supersaturated solution. Then solubility is the maximum amount of the solid that is necessary to saturate 1 dm cube of solvent at a specified temperature. Solution is a uniform or homogeneous mixture of 2 or more substances. Saturated solution is one which contains as much solute as it can dissolve at that temperature in the presence of undissolved solute particles. Supersaturated solution is one which contains more of the solute than it can normally hold at that temperature. Solubility is the maximum amount of the solute in moles or grams that will saturate 1 dm cube of the solvent at that temperature. It is expressed in grams per dm cube or mole per dm cube. Now let us consider some illustrative examples. Example 1. 12 grams of solid potassium triazoochloride 5 were added to 40 grams of water and heated to dissolve all the solid. As the solution cools, crystals of potassium triazoochloride 5 started forming at 66 degrees Celsius. What is the solubility of potassium triazoochloride 5 at 66 degrees Celsius? We are given the relative atomic masses. Potassium is 39, calcium is 35.5, oxygen is 16. The options are as follows. A. 2.45 moles per dm cube. B. 0.245 mole per dm cube. C. 0.0245 moles per dm cube. D. 2.045 mole per dm cube. Let's now consider the solution. Okay, now the 12 grams of potassium triazoochloride 5 will first be converted to moles by dividing it by the molar mass. Now, molar mass of KClO3 is 39 plus 35.5 plus 3 times 16, that is 39, plus 35.5, plus 48. This gives us 122.5. And so number of moles is mass in grams, which is 12, divided by 122.5. And that gives us 0.098 moles. That is to say, 40 centimeter cube of water dissolved (0.098 mole of the salt). Therefore, solubility is normally calculated for 1,000. Dissolve 0.098 divided by 40 multiplied by 1,000. When properly evaluated, it gives us 2.45 moles per dm cube. As seen clearly by the solution, the correct option is 2.45 mole per dm cube, and that is A. Let's consider the second illustrative example. If 50 centimeter cube of a saturated solution of potassium chloride at 30 degrees Celsius yielded 18.62 grams of the dry salt, calculate the solubility of the salt at 30 degrees Celsius. We are given the relative atomic masses, and potassium is 39, chlorine is 35.5. The options are as follows. A, 0.599 moles per dm cube. B, 0.499 moles per dm cube. C, 0.0499 moles per dm cube. And D, 4.99 moles per dm cube. Solution to example 2. We start by converting the given mass to moles by dividing it by the molar mass. So molar mass of potassium chloride is 39 plus 35.5. This gives us 74.5. And so we divide this by the molar mass, that is number of moles is mass in grams, 18.62, divided by molar mass, 74.5. And when calculated, it gives us 0.249 moles. So this number of moles dissolves in 50 centimeter cube of water. We now calculate the number of moles that dissolve in 1 dm cube or 1000 centimeter cube of water. Now 50 cm cube of the solvent dissolve 0.249 moles of the solute. Therefore, 1000 centimeter cube of the solvent dissolve 0.249 divided by 50 multiplied by 1000. And that gives us 4.99 mole per dm cube. From the solution we saw on the board, the option is 4.99 moles, and consequently the correct answer is D. Example 3. The solubility of copper 2 tetraoxide 6 is 75 grams in 100 grams of water at 100 degrees Celsius and 25 grams in 100 grams of water at 30 degrees Celsius. What mass of that salt will crystallize if 50 grams of copper 2 tetraoxide 6 solution saturated at 100 degrees Celsius was cooled to 30 degrees Celsius? The options are A, 0.145 grams, B, 1.450 grams, C, 14.50 grams, and D, 0.0145 grams. Let's now consider the solution and come out with the correct option. Now, solution to example 3. Solute plus solvent equal to solution. Now, at 100 degrees Celsius, the solute is 75, the solvent is 100, and the solution is 475. Then at 30 degrees Celsius, the solute is 25, the solvent is 100, and the solution is 425 grams. So on cooling from 100 to 30 degrees Celsius, 175 grams minus 125 grams give us 50 grams. That is to say, 175 grams of saturated solution gave us 50 grams. Therefore, 50 grams of saturated solution give us 50 divided by 175 multiplied by 50 over 1. When properly evaluated, it gives us 14.5 grams. So, as seen from the calculation, the correct option is C, 14.50 grams. Let's consider the fourth illustrative example. A saturated solution of silver chloride was found to have a concentration of 1.30 times 10 to the power minus 5 mole per dm cube. Calculate each solubility product. The options are A, 1.66 times 10 to the power minus 10 mole squared dm cube to the power 6. B, 0.169 times 10 to the power minus 10 mole squared dm cube to the power minus 6. C, 1.59 times 10 to the power minus 10 mole squared dm cube to the power minus 6. D, 0.159 times 10 to the power minus 10 mole squared dm cube raised to the power minus 6. Solution to example number 4. Now, solubility products simply means solubility multiplied by solubility. And so solubility products is 1.30 times 10 to the power minus 5 multiplied by 1.30 times 10 to the power minus 5. When it is multiplied out, it gives us 1.69 times 10 to the power minus 10 mole squared dm cube to the power minus 6. So the correct option is 1.69 times 10 to the power of minus 10 mole squared dm raised to the power of minus 6. Let's go over to pick the correct option. From the solution as seen on the board, the correct option is 1.69 times 10 to the power minus 10 mole squared dm raised to the power of minus 6. And consequently, that option is A. Let's consider the last but not the least example under this topic. The molar solubility of silver tetraoxide 6 is 1.5 times 10 to the power minus 2 mole per liter. Calculate the solubility product of the salts. We are given the options. A is 1.35 times 10 to the power minus 5 mole squared per liter squared. B, 13.5 multiplied by 10 to the power of minus 5 mole squared per liter squared. C, 0.135 times 10 to the power minus 5 mole squared per liter squared. And D, 1.45 times 10 to the power minus 5 mole squared per liter squared. Let's find out the solution so that we can locate the correct option. Solution to example 5. The salt dissociates as shown in the equation to give silver ion plus SO4 minus 2. And so we are given the solubility as 1.5 per 10 to the power minus 2, 1.5 per 10 to the power minus 2. So this gives us 3.0 per 10 to the power minus 2 multiplied by 1.5 per 10 to the power minus 2. And so the KSP, that's solubility product, is 3.0 times 10 to the power minus 2 squared because of this coefficient 2. So this one is squared. Multiplied by 1.5 and 10 to the power minus 2. So when this is properly evaluated, 9.0 times 10 to the power minus 4 multiplied by 1.5 times 10 to the power minus 2. So when properly evaluated, it gives us 13.5 times 10 to the power minus 6. And this cannot be written in standard form to give us 1.35 times 10 to the power minus 5, which is the correct answer. From the solution obtained on the board, the correct answer is A, 1.35 times 10 to the power minus 5.